A typical galaxy contains hundreds of billions of stars, but if you could hold it in your hand, it would be mostly nothing. Vast, organized nothing, wrapped around an invisible skeleton of dark matter that outweighs everything you can see. When astronomers say galaxy, they mean a gravitationally bound ecosystem on a truly absurd scale. Stars, gas, dust, planets, black holes, and an enormous halo of dark matter, all orbiting a common center of mass over billions of years. Gravitationally bound is the key phrase. Every star is in free fall, following curved paths through the galaxy's combined gravitational field, the same way planets orbit the Sun, just with orbital periods of hundreds of millions of years instead of a single year. If you could watch a galaxy in extreme fast forward, it wouldn't be a static picture from a textbook. It would look like a living whirlpool of matter, constantly moving, colliding, and recycling itself. On average, galaxies are about 100,000 light-years across. That means light, the fastest thing in the universe, moving at 300,000 kilometers per second, takes 100,000 years just to cross from one side to the other. Our own Milky Way has a mass of roughly 1 trillion times the mass of the Sun, and yet if you spread all that material evenly across its disk, the average density would be far emptier than the best vacuum ever created in a lab on Earth. So a galaxy is not a solid object. It's more like a massive self-organizing weather system made of stars and gas, shaped and stabilized by gravity and dark matter. Galaxies come in several main flavors. There are spirals like the Milky Way and Andromeda, with flat rotating disks, curving spiral arms, and thin layers of gas when new stars are still being born. There are ellipticals, which look like smooth, three-dimensional footballs or spheres of old stars, with very little cold gas left and almost no new star formation. And there are irregulars, chaotic, lopsided systems that have been tugged, stretched, or slammed around by gravitational encounters. These shapes are not cosmetic. They're fossils of each galaxy's history, how much gas it started with, how violently it formed, and how many collisions and mergers it has survived. Every large galaxy we've studied closely seems to hide a supermassive black hole at its center, with millions to billions of solar masses packed into a region smaller than our solar system. In many galaxies, including the Milky Way, this central black hole is relatively quiet, just occasionally snacking on passing gas and stars. In others, when it feeds rapidly, it becomes a quasar, an active galactic nucleus that can outshine the entire host galaxy, powered purely by matter spiraling into a gravitational abyss. So a galaxy is not just a collection of stars, it's also a feedback machine, where black holes, exploding stars, and stellar winds heat and push around the gas that future generations of stars will form from. But why does any of this matter to us, sitting on a small rocky planet in one particular galaxy? Because galaxies are the basic cells of the universe. They are where almost all stars form, where heavy elements like carbon, oxygen, and iron are forged and recycled, and where planetary systems, and eventually chemistry complex enough to wonder about its own origins, can arise. If you want to understand why the universe looks the way it does today, and how a cloud of almost uniform hydrogen after the Big Bang turned into a cosmos full of structure and diversity, you have to understand how galaxies assemble, evolve, and sometimes die. The story of galaxies is the story of how gravity sculpts the universe, and to follow that story, we need to go back to a time before the first galaxy existed at all.